We are continuing with our 5.4 quiz review. We're on to the next section, which is questions 5 to 10. They look very similar to the ones, questions 1 through 4. However, in most of these, they cannot be written as the same base. So in those cases, here's the steps right here in the middle. Although step 1, we actually never use step 1 in these 6 questions, but you would isolate the exponential term. You could do that by adding or subtracting things to the same to both sides, but we don't have any setup like that. So we're really going to end up starting with number 2, and we're going to change to log form. After we change to log form, we're going to have a logarithm that is not base 10 or base e. It's not a common log or natural log, and so we're going to change to common or natural log using the formula there. This has common log, like log base 10. We could just as easily use natural log. So either one is fine. And then we'll solve for the variable. So let's get to it. Number 5. Again, the exponential term is already isolated. It's by itself. So we're going to change to log form. So remember, the base of the exponent will be the base of our logarithm. So log base 14 of 25 is equal to negative 4x. So that was step 2. Step 3, use the change of base formula. So we don't have log base 14 on our calculator, or most calculators don't, so we can use this formula in step 3 here. So log, this will be log of 25 over the log of 14 equals negative 4x. We can go ahead and put that in our calculator. I'm going to demonstrate here so we do our parentheses right. So in this case, we want the log of 25. So I need to find my log button. It's going to give us an opening parentheses there, so log of 25. We need to close the parentheses, and then we're going to divide by log, opens the parentheses for us, 14. We close the parentheses, and we hit enter, and we get 1.2197. 1.2197. I'm starting to write small here because I'm running out of room. Equals negative 4x. The reason I stopped there, it says go to the nearest 10,000th, which is 4 decimal places. And now I'm going to solve for x by just dividing both sides by negative 4. Since that number's on my calculator already, I can just go ahead and hit divided by negative 4. And so we'll write our answer over to the side here. X equals negative, we're going to go to 4 decimal places, 0.3049. And that's our answer for the first one, number 5. Jumping over to number 6, it's going to be very much the same. So we don't have to isolate the exponential. It's already by itself over here. So we're going to change to log form, step 2 here. This is log base 5 of 70 is equal to 4v. Change to log form. Now we're going to use the change of base formula. We don't have log base 5 in our calculator, so we are going to write this as log of 70 over the log of 5 equals 4v. We're going to come over to our calculator. We'll go ahead and clear this. We're going to do log of 70, close the parentheses, divided by the log of 5. And we get 2.6397 equals 4v. And then we're just going to divide both sides by 4 to solve for v. So we're going to take that answer that we got there, hit divided by 4 on our calculator, and we get V equals 0.6599. All right, on to number 7. I'm actually going to go up and zoom in a little bit. So isolate. So step 1, isolate the exponential term. It is isolated already. There it is. So we are going to change to log form. Well, this works out nicely. This is log base 10 of 5.8 equals 7 minus 6n. Well, we don't need to do step 3 here because log base 10 is on our calculator. That's what log is. So we didn't really need to write this base 10 because log base 10 we could just write as log of 5.8. So we can just go ahead and put that in our calculator. So log base 10 of 5.8 is 0.76342 equals 7 minus 6n, and now we're just solving for n. It'll take us a couple more steps, so we're going to subtract 7 from both sides, and just keep stuff in your calculator now, so we can take that previous answer in our calculator, the 0.76342, we can subtract 7 from that, so minus 7. That gives us negative 6.23, so this needs to round, 6.2366 equals negative 6n. And then lastly, we divide by negative 6. And we get n equals, so we're going to divide this. So back to our calculator, we're going to divide by negative 6. And we get 1.0394 as our answer. We're going to come over to number 8 here. And this again is a base 10. So I'm not going to be promising that you'll, so the difference here is in number 7 and 8, we have 2 terms in the exponent and 2 terms in the exponent. Both of them have to do with a 10. They won't always be a 10, so I apologize for that. So sometimes you might, if it's not a 10 or an E, you will have to use the change of base formula in step 3. However, this one does not have it. So our step 1, our exponential term is already isolated. Step 2, we're going to change to log form. So this is log base 10. However, we don't have to write it, so I'm not going to write it this time, of 12.4 equals negative 9x minus 7. We can put log of 12.4 in our calculator. Oops, let's just get rid of all this. I typed that wrong anyway. Log of 12.4 gives us 1.0934 equals negative 9x minus 7. We're going to go ahead and add 7 to both sides, which is 8. So we're just adding 7. So it's 8.0934 equals 9x. Now, normally I wouldn't say use your calculator to add 7, but I'm going to do that here just because I want that answer in my calculator anyway, that 8.0934, because now I'm going to divide by 9. So I'm going to take that previous answer, hit divided by 9, and we get our value for x. X is equal to 0.8993 because we had to round up. Numbers 9 and 10 here. Number 9. The exponential term is isolated already, so we jump to step 2. We're going to change to log form. So log base 3 of 71 equals 6b. We can use our change of base formula. So step 3, we're going to say this is log of 71 over the log of 3 equals 6b. We'll put that in our calculator, remembering to put parentheses in as necessary. .8801, rounding correctly there. And then we're going to divide both sides by 6. So that number's in our calculator, so we'll just hit divided by 6. And we get our value for b. b equals 0.6467. Number 10. Number 10 is actually, could be fit up with 1 through 4 because 16 and 64 can be both written as a base of 4 or 2. However, I'm going to do this one how we've been doing it because I want to show you that sometimes you can use the change of base formula here, and you'll see that in a minute. For 7 and 8, we didn't have to, but we have 2 terms again, so I want to show you how that works. So the exponential term is already isolated, so we'll change to log form. So log base 16 of 64 equals x minus 6. We got our change of base formula, so we can write the log of 64 over the log of 16 equals x minus 6. And so we're going to come to our calculator, we're going to plug that in, and you'll see that we're actually just going to get a whole number, or an easier number to work with, maybe I should say. So we got log of 64, close parentheses, divided by log of 16, close parentheses, and that gives us 1.5 equals x minus 6. We can go ahead and add 6 to both sides. And we get x equals 7.5. Now, I know we're at the end. We went through all the questions. There's the answers. I just want to show you something. We got values for a variable, so I'm just going to come all the way back to number 6. And we can actually check our answer. So for number 6, I'm going to clear the calculator. I want to put this back in for v. So what we can do is we can do 5 raised to, so I use my exponent button there, and I'm going to put 4 times 0.6599. And I'm going to hit enter, and it should be 70. However, we rounded that answer from our calculator, so it's probably going to be a little bit off. So I'm going to hit enter, and notice I got 69.9843967.5, which is really close to 70. And again, it's not exactly 70 because we rounded our answer. So when you check, you might not get the exact thing. And again, it's because we rounded. So I'll zoom out a little bit so you can see all the answers at once. And that's the end of that section.